Hello, welcome to this edition of Lexbe's e-discovery webinar series, and this month we are presenting Warrior's Guide to Faster Document Review and Production, Best Practices for Leveraging Review Time with Computer-Assisted Search, Document Clustering, and Predictive Coding. I'm happy to say that Stu Van Dusen is going to be doing the webinar for us today. A little bit about our e-discovery webinar series in general. These topics take place monthly and cover a variety of relevant e-discovery and litigation document management topics. If you have any technical issues or questions during the webinar, please email us at webinars@lexbe.com and somebody will get back to you right away. A little bit about Stu. Stu's an e-discovery solutions consultant with us here at Lexbe, and we're a provider of cloud-based litigation processing, review, and document management software and e-discovery services. Stu specializes in working with firms without a full in-house legal department handling the e-discovery in complex litigation that requires a high degree of precision and e-discovery expertise. With that, I will turn things over to Stu. Thank you, Stu.
Thanks, Gene. So today we're going to be talking about different technologies that litigators can use and apply to their review methodologies to sort of make things faster and constrain and manage the different limited resources that we're dealing with in these matters. So we're going to start that out by talking a little bit about how and why traditional linear reviews have been constrained by these increasing document volumes. Then we're going to introduce the concept of improving throughput and maybe even the results of the review that you do by applying these different technologies to your workflow. And then at that point, we're going to take a deeper dive into some of the specific technologies that are in use today that'll help solve the problems that are created by this overwhelming collection volume and increasingly document-intensive cases. So we're going to take the crawl, walk, then run approach as we move through this discussion, starting with keyword search and its underlying technology, then near duplicate groupings, and finally onto predictive coding or assisted review. So what you're seeing here is the fundamental reason why we need alternative review methodologies. Not only is there a significant increase in the amount, types, and sources of data being generated worldwide, but the more practical implication that we have here is that this information is all potentially subject to a lawsuit. So even more critical to understand here is that these practice areas that didn't see unmanageable volumes of data 10 years ago, even 5 years ago, are now seeing tens of thousands of documents show up in a relatively straightforward case. So in other words, as time is passing us by here, managing large volumes of document data is becoming even more of a practical concern for every single litigator out there. But the problem that remains is that law offices can hardly staff for these kinds of cases where the data volume is unknown. And on top of that, over the course of a year, there's likely very little predictability or consistency in that volume of data. So as you're encountering these new matters and they have data challenges that deviate from your typical review workflow capabilities that you've got in-house, you're going to run out of those of some kind of resources, whether that's time, money, or people, unless you can appropriately choose and manage technologies that can drive efficiency through in your processes. And like you can see here on this slide, our goals don't change when we have a data-dense case. We're still trying to reduce the volume of documents as we pass through these case stages and increase their overall relevance. But we may need some additional assistance to get us there within our timeline and within our budget. So one approach that's often taken when we want to conduct a traditional linear review on a document-intensive case is to just bring in more attorneys and paralegals onto the case. And in some instances that might be practical, but it's definitely an expensive solution. In fact, if you take a look at where the largest costs are related to e-discovery, you can see that review is where it really gets out of control. And even within those review costs, it's most often the costliest route to go is to fill that gap with outside counsel. And of course that makes sense because we need to complete the review within our deadline, and outsourcing review is a straightforward It's probably something that we've done before, even if it is an expensive solution. And so that kind of raises the question and the point of our presentation. When we run into these problems that are caused by resource constraints, what can we do? Well, we can actually use different technologies to solve these problems, and we can do it at a predictable cost, both in terms of how long the process is going to take and how much money it's going to cost. So to explicitly define what we're talking about here today, a technology-enhanced review is any one in which additional applications, algorithms, or indexes are applied to a document set in order to support the logical grouping of documents or automatic coding of documents based on some degree of human input. And when these approaches make the most sense is when litigators need to apply something or a workflow or methodology to the review when some resource, whether that's time, money, or people, is critically constrained. And so keyword search, as I mentioned, actually, we're going to start our journey into these specific technologies with something most of us are probably fairly familiar with, and that is a keyword search. So we may take keyword search and sort of seeing it as a technology, we might take that for granted. It is a straightforward, it's easily applicable method for reducing the volume and time that we may need to sync into a document-intensive case. But instead of taking a first page to last page linear walkthrough of the collection, what you can do instead with keyword search is group these documents, group the collection into keyword-based batches, designating whether the appearance of a keyword, a group of keywords, or some kind of Boolean expression may identify documents that are responsive, non-responsive, privileged, or related to a specific issue within the case. And keyword search is at the root of several different processes that we use. Keyword search comes in during culling. It's certainly applicable to responsive and privileged review, like I just mentioned. And then later on in the case, it's extremely helpful for being able to quickly identify documents that you might need to prep for a deposition or bring into a deposition. And then by the time we're at trial, keyword search is going to have helped us really identify what those key documents with that last final set of critical documents are going to be. And so on top of these features that keyword search has, there's also some very specific benefits. So when we can have a methodology or workflow that's relying on keyword search, we can definitely speed things up when compared to a linear review. So it's very fast, and depending on what kind of platform you're using and the resources behind that platform, it can be so fast that searching 10 different iterations of a basic search in order to come up with that ideal grouping that you can pull back and then code consistently. That can be done very quickly if you're using if the service that you're using has a scalable back end to deliver the kind of computing resources you might need. Compared to some of these other alternatives that we've been talking about here, this is very inexpensive. This does not have any added cost to be applying iterative searches and working up different Boolean expressions to get to a collection or a filter that you're really trying to go to. And then quality, again, depending on the index that you're basing this search on, and we'll certainly talk a little bit more about that. There's a great degree of quality that you can get out of this, and if you compare the manual process of human eyes going page to page to page to page versus trusting a computer to pull back any hits on a text expression, the former has a lot of additional possibilities where it can fail, whereas the latter is a little bit more robust. So I was just mentioning there that we have different indexes that are going to be behind different approaches to keyword search, and that's really important because whenever we're talking about keyword search, we need to keep in mind that not all search is built the same, and that there's an incredible amount of technology that underlies a well thought out search process. And where that all starts and ends is at the index and how that's created. And how that happens is going to determine exactly how reliable your search is going to be for delivering back all of the benefits that we just talked about. So at Lexbe within our platform, our index is based on both an OCR and a native extraction of the document, and that's rare. It's not something that we've seen elsewhere. And on top of that, we're actually able to support search not only from that OCR native extraction, but across foreign languages as well. So that means that you'd be able to actually search whether or not you were using the English or the native language of the collection, and you're going to return results in both languages. And the goal that we have in developing that capability here is to take all of those potentially massive benefits that keyword search can provide, and then fill any possible holes where that can be misused or things can go wrong, and generally just trying to get it to the point where attorneys can absolutely rely on the integrity of these search results coming back. So let's take a little look here at a practical example of what I'm talking about, using an example of a PowerPoint presentation that might have been collected here. So you can see here on our first slide we've got a PowerPoint, and we've got different elements of the PowerPoint: the title, body text, speaker's notes, and this is what we would get from a native extraction. We would be able to extract the title, we would be able to extract the body text, even a comment and a speaker's note, but what we would be missing here is actually the subject of the PowerPoint. We're missing the actual financial data that would be appearing in this slide, and that's a problem. But if we just applied an OCR extraction, we would be able to pick up that body text. We'd still get the embedded image, we would still get the title, but what we would miss at this point are any comments, track changes, or speaker's notes, which could absolutely and often have in our experience contain critical case information that ends up being material at trial. So within our system, what we're doing when we index both of those, both the native and the OCR, is we're creating a comprehensive coverage of everything that you're going to see within that document: the body, the embedded image, speaker's notes, track changes, everything. And so that way, when you're conducting a search, you know that you're searching the entire document rather than fragments of the document. So moving past keyword search here, we'll take a step up in degrees of complexity, and we'll start talking about near duplicate detection, or NearDup groupings. So near duplicate detection, that's basically an algorithm that's looking for similarity across these large sets of documents. And when the algorithm does find similar documents, it logically groups them together. And so the main conceptual benefit of applying this kind of technology is that it takes an unordered series of documents and introduces some level of organization to them. So more specifically, the organization it creates groups together documents that, again, are very likely to have the exact same coding designations. So instead of seeing emails from one specific chain sporadically as you move through thousands or millions of documents, causing you to have to recall, remember, sort of rework this document, you can actually move through the email chain logically and even automatically if you're confident that the chain can be coded consistently. And so here are the four main applications that we have of near duplicate detection and grouping as they work for our clients currently. The first one I was just alluding to is grouping similar documents, and that's really at the foundation of this, is just being able to put together highly similar documents in one place, so they can either be one by one reviewed if that's the preference, or reviewed as a group if the confidence is there to do that. Finding hidden or key or hot documents. So we may have been able to identify so far in our review 6 or 7 key documents, then we add additional documents to the review collection, and what we'd really like to do is be able to quickly identify which ones of those might rise right up to the top with those other key and hot documents we've identified. Third thing is preventing inadvertent release of privileged information, and of course we all know how important that is. And also to enable email threading, and again, that's a sub benefit of grouping similar documents. But when it comes to reviewing emails, it makes a lot more sense to maintain those email relationship or email conversation relationships, so that you're reading things logically rather than just sort of randomly as they appear in your selection. So just to demonstrate a little bit what we're talking about here with NearDup groupings and just sort of grouping everything and how that makes things more efficient, here's an example of a case that had about 20,000 documents in it. And so we apply NearDup groupings, NearDup analysis to this collection, and what we actually see here is that within the top 50 groups, that we were able to create. So this went through 20,000 documents, and it created 3,425 near duplicate groupings. So there's an average of about 6 documents per group across all the groups. But if you look at the top 50 groupings that we've done here, that contains about 4,500 documents of the 20,000 document collection, and that's fantastic for us, because basically 25% of the case is going to require us to look at 50 groups instead of 5,000 different documents independently. So the time saving you're going to have there, that's 100 times fewer instances that need to be evaluated. And again, because of the integrity of the underlying algorithm that's at work here, you can rely on the accuracy of those outcomes. So as I was briefly mentioning, we can also support the threading of emails using our near duplicate groupings. And whether you're able to code an entire email thread or if it needs to be reviewed message by message, what this technology does allow is for you to read through that thread logically, and again, reduce the amount of time and maximize the efficiency of your attention. And what I mean by that is that it's easier to read a conversation sequentially than randomly distributed throughout a collection. And perhaps even more beneficial than that is that the thread is grouped automatically, rather than you having to actually assign the task of parsing out MSGs and having somebody on your review team actually manually put those conversations back together, which is something that we've heard from our clients is happening all the time. And you've got somebody spending many hours doing that, pulling those emails out and lining them up so that they can be reviewed logically. And this application would do that automatically. And so maybe the most popular application that we see of near duplicate detection is the ability to identify those potentially privileged documents that haven't been appropriately coded yet. So after you've reviewed a collection, you're preparing for a production, what NearDup technology gives you is a second level of defense against that inadvertent privilege waiver by running the content of all privileged documents against the content of all the other documents to identify those potential inconsistencies. I mean, this is such a powerful application because it creates another layer of safety between the litigation professional and the negative consequences of inadvertently waiving privilege claims. And we've heard more than a few stories about this where this process has in fact identified a yet-to-be-seen document that may have been added late in the process that they did certainly not want to produce, and because of this feature it's flagged before production and they did not produce it. So our last specific technology that we're going to talk about today is technology-assisted review, predictive coding, several other names that go along with that as well. And predictive coding truly is an incredible technology because it is introducing machine learning into the world of e-discovery. And predictive coding is being used more and more in different cases, and the main driving factor behind its use is data growth. And what technology-assisted review promises to do is allow a human being to review a small set of documents. And this small but significant input trains a computer algorithm to then apply responsiveness coding based on patterns observed in the human-coded review set. Now, predictive coding can be very expensive, but it's usually deployed in massive cases with tens of millions of documents where the outsourced review alternative would be that much more expensive. Like you can see here. And if you recall from earlier in our presentation, we were talking about some statistics related to review costs, and what you can see here is that any opportunity that we have, especially on a massive scale or on a massive case, where that 73% of total expenditure may represent millions of dollars of expense, one of the best opportunities we have to save money to reduce that expenditure on an extraordinarily large volume case is to go ahead and apply that predictive coding technology. And the benefits are very straightforward, and they're right at the subject of what we're talking about here. Applying predictive coding is going to allow you to increase the speed at which you can review these collections. It's going to reduce the cost of reviewing that collection insofar as long as you have a large enough collection for that cost benefit to make sense. And maybe most surprisingly to hear today is that it can actually potentially increase the quality of your review. There's been a lot of studies that have been done, and we're going to talk about a couple of them here in a minute, that have presumed that the quote unquote gold standard of manual review is not necessarily such a gold standard, and that some of these technologies may actually deliver more consistent results across a document collection. But before we get into that, let's talk about a little bit more specifically how predictive coding works. So basically what we have here is we have a collection of documents, and the first step is we've got to train the algorithm. We've got to give it some sort of input so it understands how, when it's moving through the remainder of these documents, it's going to be able to designate their responsiveness, privilege, etc. So the way that happens, and this gets a little bit statistical, is that we need to pull 2,400 documents out of the collection. And it doesn't matter how big the collection is, as long as we've pulled approximately 2,400 documents out of the collection, we've got our seed set. And so then what we do is we put a skilled document review professional, somebody who's very, very good at this, somebody hopefully enjoys doing this kind of review, and we put them on this 2,400 documents, and they do their very best job and their very best input on those 2,400. Then the coding decisions that are made with that review set, that's going to be the basis of training the predictive coding algorithm for the remainder of the document, and that's why we stress the quality of the training on the seed set so highly. So then after the seed set's been trained, what we do at that point is we start a QC process of checking the results of what we've done. So what's going to happen is we're going to get 25 documents at a time from that the computer has reviewed, that the algorithm has reviewed. And our responsibility at that point is to say whether or not that's a correct designation. The computer said it was responsive. Was it actually responsive? So we're either confirming or we're overturning what the computer has done, what the automatic coding has done. And the reason that we're doing this is because we're actually refining the algorithm as it moves forward into the remainder of the collection. And so the final step, once we've gotten to a point where our metrics look good, and we'll talk a little bit more about what those metrics are in a second, but where the metrics look good, we're getting consistent groups back that are coded correctly, that's when we decide to apply the algorithm, apply the patterns that we've observed to the remainder of the collection, and that then is going to give us the final responsiveness coding results that we're looking for. And so when we're evaluating any run of predictive coding or technology-assisted review, we have some pretty key metrics, and we won't dive into the really complex ones today, but just to talk about the important ones that are going to be consistent. We have F scores, and what the F scores are is a blended measure of precision and recall. And precision and recall are two terms that we use when we're talking about TAR, because precision means how often does the algorithm accurately predict a document to be responsive? In other words, the percentage of the produced documents that are actually responsive. And when we're talking about recall, what we're talking about is what percentage of the responsive documents in the whole set did we actually correctly classify as responsive. And so we have some practical ways of looking at this recall and precision question. And what you're seeing here is actually an example of perfect recall, perfect precision, and that's what that's the holy grail of predictive coding. If we can get a result like this, this would be a perfect F score. And what you're seeing here is that every time the algorithm determined something was responsive, it was correct in making that designation. So we have all of the potentially responsive documents in the collection have been appropriately marked, and what we have none of is documents that aren't actually responsive that have been marked responsive. So this is a clean result of technology-assisted review. So a situation where we would have low recall but high precision would be one where every document that we did identify as responsive was in fact responsive, but since there was low recall, we were not identifying all of the responsive documents within the collection that were responsive. And so if we produce that, we're in danger of underproducing to opposing counsel in that scenario. And that's what these recall and precision scores can signal you to relatively is are we at risk of overproducing, underproducing, or are we in a defensible spot with this? And so if we're worried about overproduction, That's what we're seeing here with a high recall, low precision situation. So we have correctly identified all of the responsive documents within the set, but we've also identified a tremendous number of documents as responsive that are not actually responsive within the set. So if we do that at something like you see here at the scale of a 10 million document collection, a lot of what we produce is not going to be relevant, and it may be a situation where we're overproducing. Like I mentioned earlier, the key here, and I know what attorneys are very concerned about in terms of actually using this stuff, the benefits sure do speak for themselves, but it's really a matter of defensibility. What are judges saying? What are courts saying? What's the precedent on this? And because of that growing volume of data that we've talked about, that really underlines the challenges that we have in review, groups like the Sedona Conference and TREC have absolutely, for years now, have been saying that this is very promising technology, and that this is potentially more reliable results, more accurate results than people can get when doing a review of 1 million documents across 25 different human beings versus the consistency you can get from one pattern and one algorithm through a predictive coding application. And so this myth that the best way to get through a document one by one, although true in many instances, it starts to break down at volume, and this is what's been studied, and this is what's been observed, and so it really creates an opportunity to use these technologies and not be concerned that there'll be a defensibility issue with it down the road. The one issue that does come up and is stated very plainly within Sedona Conference opinions about these kinds of technology applications is that transparency is king. If you're going to use something like this, you need to be able to explain exactly what's happening at each stage of the process. So when you're looking at different assisted review and predictive coding offerings that exist out there on the market, some of them are going to be more forward than others about exactly what's kind of going on behind the scenes. Others are going to be sort of a technology assisted review black box. You'll certainly understand that you need to collect your data, and you certainly understand that on the back end you're going to get some responsiveness designations for this data, but in between, if you don't know what's going on and a judge asks how exactly did this application of technology assisted review proceed in your case, and you can't explain it, that's a bit of an issue. And the other thing to definitely bring up here is that this is not something that can be applied in just any and all situations without any understanding of exactly how the methodology works. And oftentimes, what it really takes is some sort of consulting with experts to understand not only how it applies to my case, but what kind of outcome can I expect in my case when I apply predictive coding. Give you a quick run through of our very transparent application of predictive coding. There are our steps again, and what we have that's going on in ours, and this is the key thing to determine about any assisted review application that you're going to use, is what's that underlying algorithm based on? Is that underlying algorithm based on something that's not biased in the sense that it's been built to do just what it's supposed to do, which is classify things into bin A or bin B? Or do we have a biased algorithm that's been tweaked in order to maximize those outcoming F scores? And this is an interesting discussion for another time. But the issue with an F score, and that you'll see with the Sedona Conference and others who are commenting on this, is that it's not that you can compare F scores case to case and say, I had an F score of 0.8 on this one and 0.6 on the other, therefore the 0.8 case was a better application of technology assisted review. That's not the case. There's a lot of factors that need to be evaluated to determine whether or not TR worked on your case. And the first place to start in order to make that evaluation is knowing what that underlying algorithm was on the application. And the last point to make on technology assisted review is that even though it promises to be an excellent solution to these large volume cases, and as we've seen, there's many authorities that say that this is actually getting us a more reliable result. The time question comes back in, because if we are applying predictive coding to a really large case, that's still going to take a lot of time if we don't have the right technology infrastructure, computer infrastructure set up behind it. So, for example, for our predictive coding application, not only can we do that, not only do we expose an open algorithm, but because we're backed into a practically infinitely scalable computing environment, we can also do those predictive coding jobs extremely quickly. So hundreds of gigabytes of native data, predictive coding on that. All that needs to be done is understanding of what's the timeline of this particular project, how many computing resources would be needed to apply to the project to reach that timeline, and then we're sort of off to the races on getting that done. So that's the end of anything new that we want to talk about today, and I'll just quickly summarize some of the things that we've been talking about. So as we move forward here, and the years go by, and we increase exponentially more data, exponentially more documents that are finding themselves into these different matters, we really are being more and more pressed into using some different technologies to help control those resource problems that we talked about: running out of time, running out of money, not having enough people to get things done within the time and money allotments that you have. And today we talked about a few different technologies that we have here at Lexbe that we can apply to a case to help out with that. We talked about keyword search and the importance of having a multi-index behind that keyword search. We talked about near duplicate groupings and all the benefits that they can confer. And lastly, we talked about technology assisted review and some of the issues that can come up there. And certainly, we're available to answer any additional questions that you may have, and happy to show you how any of these technologies or applications work directly, either on some sample data or on some case data that you have. And all you have to do is get in touch with us, and we'd be happy to show you more. But thank you everybody for your time today. I really appreciate sticking with us through this, and with that, I'll hand things back to Gene.
Well, thank you, Stu. That was a fantastic and comprehensive overview of technology enhanced review and ways for lawyers and staff to do faster document review and production. Very well explained. I want to thank everybody in the audience for attending. We'll be making available to all the attendees, and we'll send out an email within the next day, and there'll be a recorded streaming video version, also an MP3 podcast version, and a PDF of the webinar slide deck. And please feel free to forward this to any colleagues or friends who you think might be interested. Following this, there's going to be a brief survey that takes less than 5 minutes. Please appreciate if anybody that can stick around and fill that out. We take those comments very seriously and review them all and use those for how we do these in the future. You're also free to please email us or with any questions or comments or suggestions, and we'll respond to every one of them. And for future webinars, if you want to make sure you're on the list or get anybody else on, you can email us at webinars@lexbe.com or follow us on LinkedIn, and you can see the links there. Also, our contact information there. Stu Van Dusen has been the excellent speaker here, and you can see his phone number and email address. You want to contact him, and I'm Gene Albert, CEO of Lexbe, and my contact information. And then just lastly, I want to tell you a little bit more about Lexbe. Our market is to litigators, primarily in smaller firms and smaller legal departments that wanting to use cloud-based e-discovery tools in this. We have a full-service solution of processing, review, and production. It allows you and your staff to do this completely do it yourself with no user fees or case fees. We also have a highly trained professional staff, e-discovery experts that can jump in and assist for you as needed to make sure you've got the staffing to get these things done. As part of this, as Stu mentioned, we have very high-speed, high-capacity, secure processing that allows us to really, I think, match throughput and quality of anybody in the industry. If you're interested in learning more about Lexbe, price quote, consultation, demo, free trial, please let us know, and somebody will contact you right away. Again, thanks everybody for attending, and we'll look forward to talking with you next month.